Welcome to Physics with Mr. Brazil. Today we're going to be learning about projectile motion from a height, okay? And if you read the problem, an object is going to be launched at 32 degrees at a velocity of 22 meters from a height of 15 meters. So we got 15-meter height. And we have it being launched with an initial velocity and at 32 degrees. Okay, and what is the distance from the base of the height it will land, and what is the maximum height? So in other words, we have the base of this height, and let's get a different color, and it's going to shoot out and land somewhere in a parabolic fashion. So we have a distance x, delta x, from the base to where it lands, and we also have a maximum height that's above the original height. Okay, we're going to determine that. So first of all, we need to understand that the initial velocity is the resultant vector. Okay, and that is made up of two component vectors. Vx initial, here's theta, and we have Vy initial. And in this case, Vy initial is not zero. If an object is being rolled off a height, then the initial velocity is zero in the y direction. So in this case, you need to use your trig functions and also understand that Vy initial can be transposed. It can be moved over. So Vy to make a right triangle. So Vx initial is going to be Vi cosine theta. So that's your trig functions. And Vy initial is going to be Vyi sine theta. Okay. With that knowledge, you can start using your kinematic equations. Now, let's start with y. Vy initial equals Vy initial. Vy final, equals Vy initial plus Vy initial t plus 1/2 gt. In the y direction, we have acceleration, and it's due to gravity. But for the x direction, we're going to have x final equals x initial plus Vx initial times t plus 1/2 ax, acceleration in the x direction, t. But there is no acceleration in the x direction because Vx is a constant velocity. There is no acceleration. So the initial velocity and the final velocity in the x direction will be the same. So that changes a couple of things. Well, let's start first with the y direction. First of all, Vy final is 15 meters. Y is 0. Why is this so? Well, you put your coordinate plane right where things start. Vy will be initial, and then since this is going downward, y final is going to be negative 15 meters. Okay, so we need to put a negative right here on the 15. All right. So now let's look at the x direction. The x direction, well, we can move the initial velocity, so that'll be delta x, is going to be equal to v, and I'm going to change this to Vi cosine theta times t. Acceleration is 0, move the delta x over, and if we look at both equations, the y direction and the x direction, t is common to both, and that's important. So all three vectors vectors share the same time. Okay, now, same time. Now, you can slow down the video, you can pause as I now start trying to solve this. The cool thing here is we're going to find time, and time is for the total time or total air time, total flight time for this object. So in this case, let's go and look at this quadratic equation. See, the other one, we have two unknowns. We don't know the distance for the x direction. We don't know the time. But we know the distance going downward, and we don't know the time, but we can solve for time. It's a quadratic equation. So let's set this up. So we're going to have 0 equals 1/2 gt squared plus v initial sine theta t minus y final. Okay, now let's put in some values. So 1/2 negative 9.80 meters per second squared. I'll get rid of the units, but right now I want you to see that things work out. And you can use 10 or 9.81. It's all going to work out. T squared plus the 22 meters per second times sine 32 degrees and times t minus 15 meters. Okay, let's bring this all together. So we're going to have negative 4.90 t squared plus the 22 times sine is 11.66. I'm going more sig figs for now. I'll bring everything down to the proper sig figs because we're only good to 2 sig figs. And times t plus 15. Well, let's use the quadratic equation. So t is going to be equal to negative 11.6 plus or minus, so we're using the quadratic equation. So 11.6, I'm going to put this in parentheses, squared, minus 4 times negative 4.90. And again, you could put the units in here and it would work out just fine. So 15. I just want to do this for the convenience of saving time. 4.90. And you're going to have t equals a negative number, and that's going to be a negative 0.926 seconds. And that represents actually the parabola going the back end. If you look up here to the right at the drawing, that's just in green. That's just the time behind the parabola. Not needed, but good to know. So we're not using this, but we do know that t is going to equal 3.31 seconds. Again, I could bring this down to 2 sig figs, but I'm going to use this time. Here's the beauty again. This is the total time for the flight path. So we could have made a question saying, hey, what's the total time flight? There's your answer. Now we can use this to find the distance from the base. So delta x equals, and I'm bringing it over here. So delta x equals 22 meters per second times cosine, I know I can do this. Can't make that s. Cosine 32 degrees times the 3.31 seconds. That's going to give us 61.8 meters. 8 meters. I have to look over meters. Well, that's approximately 62 meters. Therefore, that to 2 sig figs is our answer. That's the distance from the base. Now, what about the height? Well, to find the max height, we're going to, and again, looking at the drawing, we're going to need this distance from here to here, and we're going to add it to the 15. So I'm going to call this delta y above. I just like to label my variables with subscripts that kind of just represent certain positions. So let's take a look. We're going to use the kinematic equation that is for velocity Vy final squared equals Vy initial squared plus 2 times g, the acceleration, times delta y above. Now, in the y direction, at the maximum, at the apex, again looking at the drawing, at the apex up here, guess what? V final is 0. So 0 squared is 0. This becomes simply delta y above equals negative Vyi squared over 2g. Well, this will be negative. And now keep the negative outside. V initial sine theta, or sine 32 degrees. Well, let's do the theta so that theta squared so that you guys see the equation. I'm racing ahead a little bit in my mind. Okay, now let's put some values. Negative, the 22 meters per second are in the parentheses, so don't forget to do that. 32 degrees squared times negative 9.80 meters per second squared. And again, you can use 10 or the 9.81, it doesn't matter. Okay, and that's going to give us 6.9 meters. Okay, now to find the total, I'll put that here on the bottom. So y total is going to be equal to 15 meters plus the 6.9 meters, which is 21.9 meters. Again, 2 sig figs, 22 meters. Boom. Now we found 3 things. We found the total time, we found the distance from the base of the flight projectile or path of flight, and we found the total height, the maximum height above the ground that this object will be. Okay, keep practicing physics, and again, you can review this video and slow down everything. Bye.